Hello, mathematicians, and thank you for coming for another math lesson. Today, what I want to look at is multiplication, but primarily we want to look at how to multiply using the area model. This is going to help break things up, help you understand place value and how numbers work together, and I think it's going to make it multiplication a little bit easier for you as you start to master this skill. So, we're going to go ahead and get started. I'm going to start with something a little bit easier, a 2-digit times a 1-digit number, and then we're going to move to 2-digit times 2-digit, and then we're finally going to move to a 3-digit times a 2-digit. And that's as far as we're going to go on those, because I think by the time you get to even bigger numbers, you might not even need the area model anymore. But until then, let's get really good at this. All right, so let's go ahead and start with our very first problem, 63 times 4. Now, when you multiply 63 times 4, if you're new to these bigger multiplication, this might be a little scary, but it really isn't. So first thing we're going to do is we're going to use our expanded notation, and we're going to go ahead and split 63 into 60 plus 3. This is sort of similar to a distributive property type thing. And then we're going to draw our area. Now, since I broke 63 up into a 60 and a 3, I only need 2 boxes. One for the 60 and one for the 3. So I've got my 60 box and my 3 box. But we're multiplying both numbers times 4. So in the first box, this row I like to call the 4's row, because everything in this row gets multiplied by 4. This is the 60 column because everything here gets multiplied by 60. And this is the 3 column, and everything here gets multiplied by 3. And you might be thinking to yourself, that's not really a big column yet. It's going to get bigger, but I want to go ahead and get in that practice because the structure is important. So we're going to multiply 4 times 60 and get 24. And of course we know that because 4 times 6 is 24. So 4 times 60 is going to be 240. And 4 times 3 is 12. At this point in time, all we have to do is add those two products up, 240 plus 12. We get 252. So 63 times 4 is 252. How's that look? Simple enough? Let's try one again. Let's do 57 times 8. Now, if you remember before, what was the first thing I did? We did the expanded notation. And we broke up 57. And then we did our 2 boxes. We had our 8 row. We multiplied both the 50 and the 7 times 8. Now, because 8 times 5 is 40, we know 8 times 50 is 400, and 8 times 7 is 56. What do I do now? I add the numbers. And we know that 400 plus 56 is 456. So 57 times 8 is 456. Now, for some of you, you're like, hey, this is really too easy. Let's go ahead and try something a little bit bigger. Okay, let's give it a try. Let's do 34 times 52. Now, do you remember the first step? It's the same again, except this time we're going to use expanded notation on both our numbers. And with the area model, this makes this very simple. Now, instead of 1 row of 2, we're going to have 2 rows of 2. Because we have to have 1 for 30 and 1 for 4, and 1 for 50 and 1 for 2. Now, do you remember I said the structure matters? It still matters when we do this. So we have our 2 row. Everything in this row gets multiplied by 2. And we have our 50 row. Everything here gets multiplied by 50. Then we go to our columns. Everything in this column gets multiplied by 30. And everything in this column gets multiplied by 4. So now I have 2 times 30 and 2 times 4 and 50 times 30 and 50 times 4. So we're going to multiply those out. 2 times 3 is 6, so I know 2 times 30 is 60. 2 times 4 is 8. 50 times 4 is 200. Now this one might be a little bit trickier to do in your head, 50 times 30. Now I know you know that 5 times 3 is 15. And a lot of people might make the mistake of just saying, oh, it's 15, then it's going to be 150. But it's not. Because both these, if you look at the place value, they're both in the tens. And when I multiply two tens, I get 100. So when I have 5 times 3 is 15. That's 15 hundreds. And 15 hundreds is 1,500. And that's how we do that. A little trick some people might do is say 100 has 2 zeros, and they're going to multiply that out and put those 2 zeros there. Now, just like with the last one, we're going to add those 4 products up. So I'm going to add 1,500 plus 200 plus 60 plus 8. I get 1,768, which means 34 times 52 is 1,768. Now let's do another one with 2 digits. Now at any point in time, if you want to pause the video and see if you can do it by yourself, please do that, and then we're going to go over it and you can check and see how your work was. For those who want to keep going. We're going to go ahead and do our expanded notation first. Then we're going to draw our area model. Since I have two digit numbers, I'm going to go ahead and do 2 rows and 2 columns. I've got 45 and 63. We have our 3 row and our 60 row. Now what number goes in this column? That's right, 40. And what number goes in this column? That's right, 5. So I'm going to multiply 3 times 40 and 60 times 40 and 3 times 5 and 60 times 5. Now, of course, we know that 3 times 40 is 120. 3 times 5 is 15. 60 times 5 is 300. And just like before, I have 2 tens, which make hundreds. 6 times 4 is 24. That's 24 hundreds, which makes 2,400. What do I do next? That's right. I add them up. 2,400 plus 300 is 2,700. Plus 120, 2,820. Plus 15 is 2,835. So 45 times 63 is 2,835. Now, if you want to practice some more of these before we go to this next one, you can absolutely do that. But it's time. Let's go to the bigger ones. 576 times 42. Again, expanded notation. This is something I know you've learned how to do in the past, so this is actually kind of why we did it. It helps us with our addition and our multiplication. Now this time, because I've got three place value places, I have to have a column for each one. This one still has 2 places, so I'm just going to have 2 rows. So I'm going to have my 500, my 70, and my 6. So of course it's my 500 column, my 70 column, my 6 column, everything multiplied by 2, and everything multiplied by 40. Now obviously our answer is going to be, we're dealing with bigger numbers now, and that's okay. So we're going to have our 2 row, everything is multiplied by 2, everything is multiplied by 40. Same thing we just said, by 500, by 70, and by 6. We're going to multiply those out. 2 times 500 is 1,000. 2 times 70 is 140. 2 times 6 is 12. 40 times 500 is 20,000. 40 times 70 is 2,800. And 40 times 6 is 240. Again, what's the next step? That's right, we add them all up. This is some bigger adding, I know. Usually in our class, we'll add maybe these 3 together and these 3 together, and then we'll put it all together again. Whatever strategy works best for you there. If you're getting the answer right every time, keep with it. But when we add these up, I get 24,192, which means 576 times 42 is 24,192. Now, every time you multiply a 3-digit times a 2-digit does not mean you're going to get an answer that big. And that's okay. Sometimes it might be. It depends on what you're multiplying. Now, again, if you want to pause the video and try this out for yourself and then come back and check your work, you absolutely can do that. If not, let's keep on watching. And this will be our last problem. 357 times 26. Again, you have the expanded notation. What do we do next? We build our area model. And we label our sides. 300 times 57, 26. And everything in this row gets multiplied by, and everything in this row gets multiplied by. Hopefully you got that right. And of course, everything here gets multiplied by 300 in this row, this column, 50, and this column, 7. That's right. Again, I tell my class all the time, the structure is important. If you can get this part set up correctly, the rest of it gets a little bit easier. So we're going to multiply all those out again. 6 times 300 is 1,800. 6 times 50 is 300. 6 times 7 is 42. 20 times 300 is 6,000. 20 times 50 is 1,000, and 20 times 7 is 140. Again, we're going to add those up. When we do, we get 9,282. So 357 times 26 equals 9,282. Thanks for sticking with me to the end of the video. I know it's a little bit long, but we had a lot to go over, and I wanted to show you how we can use this strategy to do easier multiplication as well as to some that's a little bit more difficult, which really, when you get good at this, isn't so difficult after all. Again, thanks for sticking with me to the end, and I hope you have a fabulous day.